sets the elements themselves. A set can be simply viewed as a collection of objects or elements. CXC sets questions come into two main types. So first type is those that deal with the elements themselves, the elements in the set. And the other type is those that deal with the number of elements in a set. So either one can come in the exam. When you're doing the past papers, you're going to see. So for example, here we're going to deal with the one where the elements themselves are important. So that's what number 29 about, sets the element themselves. Let's say T and E are subsets of a universal set U such that the universal set have numbers from 1 to 12, whole numbers from 1 to 12. And T now is equal to the set of multiples of 3. Well, that's like a subset. A subset is a set, it's just part of a bigger set. And E now is the set of even numbers. Draw a Venn diagram to represent this information. List the members of the set, and these symbols, you have to know them. That symbol that look like the N is for intersection, because N intersection has an N. And this symbol is for union. Union starts with a U. And this symbol is complement, means not part of. The little accent here. So we have to draw the Venn diagram. And here's the example. The Venn diagram is a rectangular box. And in the box, you have two subsets which are interlocking to each other to give the intersection in the middle. And T now is for multiples of 3. E is for even numbers. So what we can do as a working, I can list the multiples of 3 and list the even numbers and translate it now to the Venn diagram. Because in this example, what we are seeing is that the Venn diagram was simply constructed. So here we are going to list the multiples of 3, and they are going to list the even numbers, talking about numbers from 1 to 12. So just a reminder, T is for multiples of 3, here it is, and E for even numbers, and the universal set is numbers from 1 to 12. So you have the universal set, and from that set, we're looking for T, multiples of 3. So T is equal to, and we're using curly brackets for set, not curly brackets, curly brackets. So multiples of 3 will start with 3, 6, 9, and 12. So these are the multiples of 3 in that universal set from numbers 1 to 12. Multiples meaning numbers that 3 can go into without leaving a remainder. Now, E now is for even numbers. So in that universal set, we are going to identify the even numbers or the even number. 2 is the first even number, followed by 4, followed by 6, followed by 8, followed by 10, followed by 12. So we can clearly see between T and E, there are some numbers that are repeating. These numbers are called intersections because they are found in both T and E. Numbers like 6, because 6 is a multiple of 3 and 6 is even. 12 is a multiple of 3 and bear in mind you hear the word and in set theory, and means intersect. 12 is found in set T and insert E. So these two numbers, 6 and 12, must come in the intersection. And 3 and 9 belongs to T only. 2, 4, 8, and 10 belongs to E only. And all the rest will go outside of the Venn diagram. So what I'm going to do right above there is the universal set, just to facilitate the presentation. Take capital U for universal. Numbers from 1 to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's minimize this a little bit. Here they are. And as you can see, this question is dealing with the elements themselves. What are the elements? Numbers from 1 to 12, whole numbers from 1 to 12. So we're starting with 1. 1 is not part of T, 1 is not part of E, so 1 comes outside here, as you can see clearly. 2 is even only, so 2 comes here. T4, multiples of 3, and E4 even, so 2 comes here. So this area is E only. This area is T and E. This is T only, and here is neither in T nor E. So 2 is even only. 3 is a multiple of 3 only. 6 is both multiple of 3 and even. 4 is even only. 5 is not neither multiple of 3, neither even. Comes outside. 6 is in both. 7 is neither multiple of 3, neither even. 8 is even only. 9 is neither. Yes, 9 is multiple of 3 only. 9 is odd, but 9 is multiple of 3 only. 10 is even only. 11 is neither. Actually, 11 is a prime number. It has only 2 factors, itself and 1. And 12 is found in both multiples of 3 and even. So here's the representation of the information, and here it is in the form of a Venn diagram. And here you have some extra notes, questions for practice. Now, we need to find T intersect E. So T intersect E is 6 and 12. T union E, meaning all in T and E, no repetition. So we can start with 2, 3, 4, 5 is not there, 6, 7 is not there, 8, 9, 10, 11 is not there, and 12. So these values are in the union. I normally call it sliding down 8. No one infinity sign, that is the union. And T union E complement what is not part of the union. These are the values outside there. Another word for this accent is not part of. So not part of the union. And as you can see, you can get a custom of reading from right to left. You can say T union E complement. You're starting from left to right. But you can start with the accent. You can say not part of T union E. Okay, sometimes it's better, more effective by doing it that way. In maths, practice reading from right to left. For example, this set of numbers, you can start with 11, 11, 7, 5, 1. 11, 7, 5, and 1. Not part of the union. So which values are not part of the union? Here they are, 1, 5, 7, and 11. You have the union and the value is not part of it. Here it is. You have the union and the numbers that are not part of it. But you can see the values that are not part of the union. And here they are.